Well, thank you. I'd like to start by thanking Dylan for having me here and Solke for hosting everything. One disclaimer, it's going to be a pretty technical session. We're going to have a lot of code to talk about. So,
cool.
Yeah, I hope so. Now, everything is going to be in C#.NET, so I assume some of you are working in that. Should be fine. Yeah, I mean, if you know classes, functions, lambda expressions, maybe some link queue, it's going to be a cruise. So it's fine. The code might be small for people in the back. I apologize in advance. So worst case scenario, there's seats up front. Anyway, let's go. First thing is, my name is Guillaume. I work for Vonage as a senior .NET developer advocate. You might realize I'm not from here. I come from France, in case it wasn't obvious. Bonjour. This is where you can find me. The usual GitHub, LinkedIn, stuff like that. There's also a secondary GitHub account, which is a free organization we made with a friend. Everything is free, it's open source. We share stuff about extreme programming and all this stuff. And we have a free workshop on TDD. We have a free knowledge base. We even made an escape game for it. But anyway, I'm also hosting the Software Luxembourg meetup. There's my dev.to account if you want to see what I write about. And I'm also a mentor from time to time and a teacher. So here you go. Nobody cares. Let's go next. Okay. So exceptions, just a quick show of hands. Can you raise your hand if you had to deal with exceptions at least once in your career? Oh no, 100%. Again. Well, today I'm not going to tell you how to do exceptions better or anything like that. I want to focus on a very particular scenario where exceptions happen all the time, where we use exceptions a lot. And this is validation and error handling. Okay? So just as a reminder, exceptions are a way to deal with unexpected and exceptional situations. Okay, so you do something, exception happens, technically on paper something bad happened. Okay? So let's start with an example. I have a service. How's the code in the back? Good enough? Okay, that works for me. I have a service that allows you to retrieve a user based on an email. Okay, so that service has that function, find user, takes a string, email, parameter, returns a user, and it's retrieving that user from a data store somewhere, random database, whatever. But there's also this. Okay, you have an if statement there that verifies that the email is not null or empty, and if it is, it throws an exception. That's a guard clause. That's not bad. That's a mechanism to make sure that the input matches your requirements so that you can use that value properly. I'm good with that. It's a very simple example, but that pattern, I've seen that 1,000 times. I'm pretty sure you go in your code base, you do Control-Shift-F, throw a new exception, you're going to see an if like that just before. Probably sure I'm going to win that bet. But this is not exceptional. It is not unexpected. Right. Any TDD practitioner in the room? Give me a few. One. Okay, one. We have a winner. So if you were about to test drive that function, you would start by writing a test that would verify that if I call find user of null, I get an exception. And then you would write that thing. It's not unexpected. That's a behavior. And even if you don't write tests at all, someone put that throw new exception over there. It's written. And it's not exceptional either. A null email is probably a wrong user input or something like that. So why do we use exceptions so much? Now that's a very simple example. We have 3 lines of code. Very simple to write, very fast to write. But the fact that it's easy to write doesn't mean it's easy to use. If you want to use it, and you call service.findUser of email, what do you get? You can't be sure. You can get a user, you can get null, you can have an exception. So we have sort of a transparency problem there. Okay? That method is lying to you. It's telling you, I'm going to give you back a user. Well, actually, not really. Okay? You don't know what you're going to get. And the thing is, that transparency problem has even a bigger consequence. Defensive programming, try catch everywhere. Okay? That's horrible. First, you don't know what find user is going to throw. You don't know if it's going to throw. The problem is, if it throws, oh boy, your app is dead. If you were lucky, you still had somewhere a global exception handler that was catching the thing. Why not? But you have to do that. That's very ugly. Let's talk about also the fact that we have to rely on the global exception type. This is a bad practice because it means you don't know what to happen. You don't know what to expect, sorry. This is exactly our scenario. You don't know what to expect. So throwing an exception is relatively easy, but it's like throwing a hot potato to the person that's going to use your code. Okay. And then you have more things to deal with. Oh, did I find my user or not? So exceptions are widely used this way. And they've been kind of the standard, as far as I can remember, on how to deal with error handling and errors and stuff like that. This is how I was taught at school. This is how I was taught when I joined the industry. And this is how the people who taught me were taught when they joined the industry as well. It's like that. What I want to show you today is it's not the only way. We can do differently. Better, open for discussion. We can do differently. So what I want to do is I want to challenge the type system here. Because as I said, find user is lying to you. It gives you one state. I found my user. The other two are not. I'm going to break something. What if we could be explicit and transparent on the written type? Because we are using C#, a strongly typed language. That should do the trick. Okay? The idea here is not to return one state only, but 2. You got a user, or something went wrong. User not found. You can put them 2 on the same leg. Or more, we're fine. It's fine. So now this is not something new. And actually, there's a famous metaphor to explain that. So we're going to talk a little bit about quantum mechanics. It's going to be simple, okay? You probably heard about Schrodinger's cat before. Or at least you saw someone with a t-shirt saying, hey, the cat is dead and alive at the same time, which is not really the thing, but yeah. So, Erwin Schrödinger, physicist, Nobel Prize winner, a little bit smarter than I am, a little bit. And so what he explains is basically that you have a box and a cat. The thing is, the box is not just the ordinary box that you get from Amazon or DHL or whatever, because the box is trapped, contains 2 things. So one is a radioactive element, low budget, and the other one is a mechanism that can release deadly poison at any time without you being aware of it. In other words, you do not want to be trapped in that box, okay? And so what Erwin is saying there is when you put the cat in the box and you close the box, the only way to tell if the cat is dead or alive is to open the box again. Even I could have found that one. That's super easy. All joke aside, what Erwin is trying to explain, or at least to simplify with that idea, is the principle of quantum superposition. Okay? When the cat is inside the box, it's not dead and alive. It's either dead or alive. Not both, not neither. In quantum mechanics, you have to assume that a situation can have an infinity of different states until you can make a factual observation. This is a simplification. We don't have an infinity of states, we have two. The cat is dead, the cat is alive. And how do we make a factual observation? We open the box. That means that when the box is closed, you can carry the box around, you can throw it in the air, you can shake it, you can do whatever you want with it. But you have to assume both scenarios. And as I have a very exciting life, I coded a box like that. Okay? Very simple. So a class has a field cat. Cat is a struct, so it's not nullable by default. You see the question mark. So we have a nullable cat as a field. The shortcut here is if the cat is not null, the cat is alive. If the cat is null, the cat is dead. We're going to kill a bunch of cats. I'm sorry, don't sue me. Also, at the bottom, we have two static factory methods to create our box, either with a cat, a living cat, or with a dead cat. I'm going to break it again. And so what do we do? First off, you can shake the box. So we call meow on the cat instance. Meow logs meow in the console. That's me being creative. We have a question mark as well. That's a null propagation operator. That means that if cat is not null, we're going to call meow on the cat. If cat is null, we don't do nothing, because last time I checked, a dead cat doesn't meow. Makes sense. And we return the box. Other things you can do, shake, too hard. You do what shake does, but then you return a box with a dead cat. That means you basically killed the cat. And finally, we have that method openBox that returns a nullable cat. That's our way to do the factual observation. How do we use that box? Well, first, take the box, put a cat inside, called shake, 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 and in the console you see meow, meow, meow. So far so good. And then, if you do shake, shake too hard, and shake again, you only see meow twice because you kill the cat on the second one and the cat is dead, so it doesn't meow anymore. I want you to pay attention to two things here. First off, no matter what we do, shaking, opening, whatever, we never manipulate the cat directly. Never, ever, ever. The other thing, there is no branching. There's no if statement to verify, do this if the cat is dead, do that if the cat is alive. Keep that in mind, we'll get back to that later. So right now we have a box with a cat that can be either dead or alive. That's fun. We won't go far. You want to integrate that in your fund management application, call me, I want to see it live. Okay. But it doesn't mean we have to throw everything away. Because we could replace literally cat by anything, like a T, a generic type in C#. So I can have a box of integer, a box of datetime, a box of object, a box of box, a box of whatever. Now the thing is our two states, what does it mean if I have a box with an integer inside? A box with 3, dead and alive, makes no sense. So we have to adapt this a little bit. And we were relying on nullability to define whether the cat was dead or alive. So we can do that to say either I have a value or I don't have a value. That could be a some state or a non-state, for example. That will work. So I changed the box, so nothing changed. That's just C# being a bit more verbose because of generics. That's fine. The big question is, what happens to shake? Why would you shake a box with 3 inside? Makes no sense. So now the fun is over. Let's start doing interesting and useful stuff. I'm going to introduce a function that allows us to transform the value that is inside the box. Okay? Don't get scared. Map takes a function of t result. T is what we have inside the box. So the goal is to transform t into something else. And we're going to do that only when the box has something. Let me explain. I have a box with 3 inside. I'm calling map with value lambda, value plus 1. This is a function. It's a lambda expression. So value is a parameter, and what's on the right side of lambda is basically the result. Increment. Okay? So I have a box with 3. I call increment on it. I open the box, take 3, apply the function to 3, I get 4, and I put 4 into a new box, and I return the new box. Okay? Sounds difficult? Have you used LINQ before? Map is basically select. It's exactly the same thing, except that select is basically iterating on the collection. Here we just have one element. So I have a box of 3, I call map, increment 3 times, open the box, I should get 6. Now if I have nothing in the box, and I call the same function, there's nothing to increment, there's nothing to do, and the box remains empty. So if I have none increment 3 times, well, I still get none or null. It's like calling select on an empty collection. Nothing happens. Okay? Now, I don't know if you noticed, because I'm going quite fast on that, but there is like one huge limitation on our map function. We cannot change the state. Okay? If you're in the sum state and you call map, you're going to remain in the sum state, and same goes for none. Could be interesting to have something that allows us to kind of change the state. Okay? Ta-da! Let's go with bind. So bind is a new function that is extremely similar to map. There is one tiny difference. Map transform t into t result. Bind transform t into a box of t results, where t result could be another type. But more importantly, we could transform t into a box of a different state. And so the difference is that when you do map, you get the result and you put it in a box to return the box, while bind, you already get a box and you just return it. You don't have to wrap anything. So let's look at that function, for example, half, trying to get half of a value. So half returns a box of integer. And the idea is if you can get half of a value, you're going to return a box with the value inside. And if you can't, you're going to return an empty box. Okay? So I have a box with 4. I call half on it, and I get a box with 2 inside. So I have a box with 8. Half 3 times. 8 becomes 4. 4 becomes 2. 2 becomes 1. And if you have 3, you call half, you get an empty box. The state changed. So 4 out 3 times, 4 becomes 2, 2 becomes 1, 1 becomes none. And there it happened. Remember what I mentioned before? We never manipulate the value. There's no branching. Here, those 2 examples I shown, the flow is exactly the same. You have a box, whatever it is, you call half 3 times, you open box. The only thing that changes are the inputs, and therefore the output. So what did we just build? Well, a structure that can contain a value, that represents multiple states, that you can chain, and you can manipulate the value with even if you don't know the state. And this is where I have to apologize, because what we just built is called Monad. So normally this is where half the room leaves, and so I ask you, please sit down. This is fine. This is a hated term that comes from the functional paradigm. We all know that huge meme about monad being a monoid of the category of endofunctors and blah, 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 blah. That's the entire problem. The theory is a mess. The theory is overcomplicated. What I want to show you today is the behavior, the logic, what it does is not that complicated. So today, no category theory, no math. I mean, I don't have a PhD. I'm not smarter than any of you. I can do it. So, let's try to keep the theory aside and see where we can go. So this is a visual representation of what we just did. Okay, you have a box, and we can do two things. We can call bind, and in that case, we can change the state, and we have map that just transforms something. So here you have to assume that what we have on the green side is considered working, our success stuff, when we have a value. This is when we don't have a value. Okay, so we had 8. You call half, you get 4. You call increment, you get 5. You get half, end up with none. That's just a visual representation. Well, I'm not inventing anything. This has a name. It's called railway-oriented programming. It's the way to do error handling in functional languages. So that's what we just did. Now I could stop there. That would be super short. I will not. Because actually, for the box we built, I'd like to iterate on it a little bit, because there are a couple of things I don't like a lot. One is null. No more null. Null is bad. It's called the $1 billion mistake for a reason. Okay? But there is a big question. Our two states are, I have something, I have nothing. When you open the box, how do you represent the absence of value if you can't use null? You have 2 hours. The answer is you can't. What you could do instead is provide a fallback scenario. This is where I want to introduce match. And match takes 2 functions. 2 because actually it's providing 1 function per state. One that is for some state, one that is for non-states. What we're going to do is provide both. And depending on the state of the box, call the one that is corresponding with the state. Here's an example. I have a box for 3, increment 3 times, you get 6, you get half, you get 3 again. And then you call match. And match basically answers to the questions. What happens if I have nothing? And what happens if I have something? You provide the 2 scenarios. In that case, because our box contains 3, the output will be the value is some 3. And then, if you do it with 4 plus 3 is 7, half gets none, you end up calling that leg. That's a nicer way to extract the value from the box. There is one big criteria. You need to know what happens in both scenarios. That means you can't do the equivalent of having an empty catch block on that. So you have to be. Okay? So no more null, me happy. But why would we stop there? I don't know if you see what I see. What I see is function, 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 and some of them are duplicated. That's not related to Monads, but I have to talk about it. Never leave your code in that state. Never. What you should do at this time, and if you're using a proper IDE, is use something called extract method. If you're using writer, Control RM, type something, take you 10 seconds to go through this. Why do you want to do this? Not because it's fast, not because it's safe, because it reduces the cognitive load of your function. Why? Because what you do matters more than how you do it. How you do it is an implementation details. Nobody cares. It doesn't help to understand what's going on. While actually, if you're able to put a word or a sentence on logic, you're able to express intent and explanation. You don't trust me? For those who are not super used to that writing there, this is called a method group. Basically, when you're calling a function that takes a function as a parameter, if the function you pass has exactly the same signature, in our case, I take an integer, I give back an integer, you can use that and it will do the mapping directly. We remove all the noise, all the things that are not necessary. This is called declarative writing. Okay? The code suddenly looks like a story. It's like a book. When you open a book, on the first few pages, you see a list of chapters. Okay, you're reading a book about programming. Oh, chapter 7, Monads, page 75. You're going straight to page 75. If I want to see how you implement half, I click on half, I do Control F12, go to definition. I don't have to read everything. I have my chapters. Something quite cool as well is you could give that to a junior, someone who joined your team, someone who's not technical, maybe. Assuming they know what map, bind, match do, they'll be fine. What remains is intent. It's the business stuff happening. Have 3, increment 3 times, get half, and then do something with it. This is huge when we talk about writing readable code that people can understand. Okay? Has nothing to do with monads, but because we rely on functions, it goes so well together, I cannot not talk about it. One more thing. This is where the code is going to be a bit small. I don't expect you to read everything. This is our final iteration of the box. The flow plus the functions. Just look at the F# example next to it. It's not identical, it's super similar. The reason I show you this is at this stage, we're basically writing functional C#. Okay? Assuming you'd like to, at some point, try a functional language, you'll never get a better bridge than this. Because you get a language that is, well, a different language from a different paradigm, under the same .NET framework that basically look like your current code. So if you were about to try ideal conditions, you want to try Haskell, yeah, that's great. That's going to be harder than that. Scott Vlashen used to say that basically F# was C# on diet. You cut the fat, you remove. He wasn't wrong. Now I hear your thoughts, because yeah, I showed you stuff about incrementing an integer, getting half of a value, converting that to a string. I work in a complex environment where I couldn't do that, and blah, 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 blah. I hear that all the time. So I want to show you how I use them on a daily basis, okay? First off, everything we did, you don't have to do it yourself. There are libraries that do it for you. On the top, LanguageX, my favorite one from Paul Luth. Also the most overwhelming one. So if you're trying to learn with that one, buckle up or get help. I went through that. It was difficult. But it's probably the most mature one and the most complete one over there. If you were about to start, I would recommend the one from Vladimir Korykov, C# functional extensions. It's much simpler, there are less like baggage required to use it. One off for another time, not today. And so the thing is, those libraries, they kind of all expose a similar set of monads. Like I said before, it's just about states. The first one is the one we made, called the option or maybe, that exposes either a non-state or a some state. But then you have a try that represents a success or an exception. Might be useful. The result, or the either, where we call the two states a left and a right because you have full control over the types. One off, no. So it's not just about doing something else and exceptions. It has like a much wider use and approach. So I'd like to go back to our first example there. What if I try to remove that exception and replace that by a monad, for example? Ta-da! So it doesn't take like more lines of code. I just needed 3 objects to make it very explicit. The first thing you have to see is the signature. We're not returning a user anymore. We're returning either an error or a user. We're transparent. We're giving the information to the person who's going to use our code through the type system. It's not a tuple. We cannot have both an error and a user. It's one or the other. Okay? When email is null, no need to throw an exception to that. You return. If you're using an IDE, this gets this and this gets removed because they implement implicit operators. But what we do is we return a validation error. Validation failed, saying the email cannot be null or empty. And same goes when, and this is better than before, when we don't have any user, we return an error saying, hey, user missing. So same 3 lines of code, kind of. And what about using that now? That's it. And I could have inlined it, but I wanted you to see the type. So I call find user with an email. I get either an error or a result. Remember match? First leg, what happens when we have something, user found, that we were using earlier. And if you have an error, depending on the type, you're going to use that. Because actually, something the previous code didn't do. If you're building an API, telling the user a missing resource or an invalid input are 2 different error codes. So you might want to have 2 different behaviors for this. One would return a 400 and the other one a 404. We need to think about how the code is used. You might be the main user of your code, might be your colleague, or it might be someone at the other end of the world. If you're writing a library or SDK, you don't know your users. It's my case. That's what I do. So at Vonage, what we do is we provide APIs where we can do communication services like text notification, video calls, voice calls, or 2-factor authentication. We also have APIs for network APIs that use 5G networks to verify your identity and make sure you're safe and that no one's stealing your information. But the thing is, when you do APIs, That's boring. Because when you want to consume an API, you have to, I need to serialize something into a JSON and make sure that the schema is correct and everything. I need to call the right URL with the right method and put the right headers and blah, blah, blah. And then when I call it, I need to treat the response and I need to serialize it and treat the response code. We do that for you. We give SDK that are free and open source for .NET, Node, PHP, Java, yada, 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 yada. And that's my job, mostly my job. So if I write code that is difficult to use, I have between 150 and 200,000 developers that will be mad at me. So I need to think about how do I make my code easy to use. That's why. Now I'm going to show you how I use that stuff. You ready? Can someone tell me what does this do? Sorry? 8 seconds. It took 8 seconds for someone to find out. So thank you. Indeed, I'm converting a string that may contain a phone number to a phone number. Now, it took him 8 seconds to find out. He had no idea of the business or where was it used, what was it for. And he understood everything. Well, there's not a single line of code logic. You don't know how it's validated. You don't know how I verify this and this and this and this. We don't care. What I want to show him, what do you expect from that? Okay, I know what it does. And this is where you have, again, that visual representation. Okay? So here, I create a phone number with that thing, and I'm going to run that number through a list of validation rules that will eventually fail if my number doesn't match everything. So as soon as one is failing, I'm going to end up on that red track, and that's it. But maybe that's too easy, again. So let's scale up a little bit, okay? This is weird. My customers are developers, okay? So the users of my SDK. When they use my SDK, it's because they want to do something with our APIs. Like they want, for example, to verify a two-factor authentication code against a request. So they have to start with data. This is what they have. They have a request ID and the code that they received by SMS. My first step inside the SDK is to get that data and do parsing. Parsing is transforming a less structured input into a more structured output, doing validation at the same time. That's a way for me, what you've seen before, for example, let me go back to it. That's maybe better. Parsing, again. This allows something that is critical for me. It is factually impossible to create an invalid phone number because you have to go through this. So if you have an instance of phone number somewhere, you know it's valid. You don't have to check it again. So parsing. When I have my request, I transform it into an HTTP request message. That can fail as well, because this is where we have to put the HTTP headers and especially the bearer token. May fail, whatever. Then I send the request to our API. Again, maybe I get to 400, maybe I get 500. And then I need to deserialize that answer. I don't have 2 tracks, I have 4. The reason I have 4 is whatever I get from the API, whether it's a 500 or a 200, I need to deserialize the response we get. But in both cases, it can fail. My SDK may be out of date, I may have a bug, Maybe they changed the API without telling me. It happened. It will happen again. That's my end-to-end flow. It's not just about doing arithmetic operation. I have async, I have HTTP calls inside. I'm going to go quite fast on the details, but this is how they create, for example, a request to verify a 2FA code. I rely a lot on builders. You want to ask why? Ask me later. And as soon as I have the request, they just give it to my client. And from that, everything is internal for me. So how do I convert? Well, it's like before, just call bind, give it a function that will do the conversion. Then I call the client and I extract the data I need. And then, how do I treat the response? Everything is there. So when you go back to my user's perspective, that's what they have to do. Create the request with the builder. When they have the request that is finished, they give it to my client, and they call match. Again, what happened when it worked? What happened when it didn't work? That's it. A question I got a lot is, what if I don't want to use your goddamn monads? Well, I tried to find a solution to that too. Something I didn't mention, the monads I use in my SDK are not from any library I showed before. I made them my own, because reason, ask me later, who cares? But so it allowed me also to extend them. I created that function called getOnSafe. Instead of extracting the value with match, if you want, you can call that. It will open the box, trying to extract the value. If your box was not in the right state, it will throw an exception. That's my way to trying to make everybody happy. Okay. Of course, remember, if it throws an exception and you want to deal with it accordingly, you have to do something like that. Your choice. Okay? You do you, I do me. Anyway, should you get rid of all exceptions? It's tricky, because just like good old Thanos over there, exceptions are inevitable. Okay. They will happen in the code that you write, sometimes on purpose when you throw them. They will happen on the code that you write not on purpose, a null reference exception, a memory exception, whatever. And they will mostly happen in code you don't own. The code that you use from other libraries or other things. It's tricky. And if you haven't seen the movie, I'm sorry, spoiler ahead, but it's old, who cares? It got defeated by exceptions as well. So what can you do? I'm going to rely on a real example with an architecture to show you how I do things. Anyone familiar with ports and adapters? It's old. Okay. A few.
Did you say ports and adapters?
Sorry?
Did you say ports and adapters?
Yeah, hexagonal one. Can we agree that this is an hexagon? No. I was too lazy to draw one. The circle was built in, so I used the circle. So it's fine. Let's pretend. You're with me. Let's pretend. It's an hexagon.
It's a French hexagon.
So in the port and adapters or hexagonal architecture, this is the center of your app. This is where you have the business logic. This is where you have all your rules and everything. This is where your system is valuable. It's because of what's inside the domain, right? Now, in order to interact with that domain, the hexagon exposes ports on each side. These ports are contracts. What rules do I have to follow if I want to use you? And on one side, you're going to have what we call driving adapters. these are starting points of our applications. So API, front end with JS, front end with Blazor, console app, service, anything, mobile app, anything that runs. On the right side, you're going to have what we call driven adapters. Okay, these are your dependencies. What do your system requires to work? A third-party API, a database, a file system, IoT devices entirely, anything. Now the thing is, you might want to try to write exception-free code over here, and you will succeed. If you have a robust test suite that checks that for you, you will succeed. The problem is, on that side, it's a bit the far west. Okay? Because they will throw a lot of exceptions and you can't do anything about it. So the problem is, you're going to have something like, oh, I'm doing something with Entity Framework, going to save changes on my context, and DB update exceptions propagates until God knows where. So worst case scenario to the customer, don't. Or a global exception handler, or any of the other try-catch that is kind of somewhere here. For me, that's a no-go. This is nope. My domain, because of the rules of the hexagonal architecture, is supposed to be agnostic of the dependencies. It's not aware that you're using Entity Framework instead of Dapper or anything like that. So you tell me that at some point I need to have a try-catch over here that expect a DB update exception. It's breaking the rule. I should not be aware of Entity Framework around here. And how do you do? What you could do, what I did, was inside your adapter catches those exceptions, exactly where they happen. But don't let them enter your hexagon. Okay? So what your adapter can return instead is something transparent that will expose the failure, and that will remain neutral regarding the dependency. That's how I worked for quite some time. I liked it. Now it's kind of up to you to decide what you allow in the hexagon, but normally these are the rules. So, why did I want you to talk about all that today? The reason I made this talk in the first place is to give you another tool. I wanted to spread and raise awareness about Monads because it's not so fancy or so crazy as an idea. And yeah, a new tool for your developer toolbox. We all have our own, where we put practices, methodologies, patterns, ideas, fuck-ups, anything. It's called experience. Okay? The more tools you have in your toolbox, the more suited you are to solve a problem with an optimal solution. Now, should you throw exceptions or use Monads? I'm sorry, but nobody cares. I'm not saying that you lost an hour. I'm saying it's not relevant. Okay? We work in a very complex industry where the only absolute answer that you're going to get is it depends. Depends on the client, the team, the budget, the deadline, the environment, the tech. There's no silver bullet. Silver bullets are a lie. So it's difficult. I want to show you that with a quote from Mark Simon. He's one of my heroes. He wrote that in a blog post a very long time ago, 2014, when he was writing about command query separation, CQS. It's a super important pattern in OOP that you should apply 100% of the time, or maybe 99.999% of the time. And so in that article, Mark was basically at some point deciding on purpose to break CQS, which was kind of crazy to me at the time. And he leaves that quote at the end of the blog post. When I decide to break CQS, I do so realizing I'm making a trade-off, and I don't do it lightly. Trade-offs and compromises. This is what makes our job so hard. Because again, there's no silver bullet. And sometimes breaking this, it makes sense, even if it's weird. So you could take that quote and replace it by, when I decide to use exceptions, or when I decide to use monads, I do so realizing I'm making a trade-off on blah, blah, blah. And that is true. Okay? What matters is not what you use, it's why you use it. Okay? So no matter which one you use, do you know which trade-offs you're making? What compromise are you making? Do you know why you're using it? Are you able to explain that to your team? Are you able to justify it? That's what matters. So the highlight is, don't trust a random guy at a meetup or a conference. That's me, okay? What I want you to do is not tomorrow I'm gonna use monads, is no, try. Forge your own opinions. Give it a try. Next time you're gonna throw an exception, maybe it's not worth it. Or maybe I can try something else. And if you don't like it, you don't like it. But at least you tried. You have the two perspectives. I know what I would do. I would use monads. I can tell you why. I favor transparency and predictability. Okay, I know which compromise I'm making. It's not easy for everybody. The bar is a bit higher for people to contribute. I know. It is something I can justify. And yeah. So if you want to dig a bit deeper, I wrote a series of blog posts on that give me more room, time, and stuff to explain and everything. These are the resources that I either use or inspired me to do all of this. I'm going to share that with a QR code later. Don't bother taking a picture now. And so if you got any questions, please fire. I'm leaving that there. If you scan this, you basically have the list of all the resources if you're interested, plus an extract of the slide. Not mandatory, it's free, so who am I? I hope you had a good time. I hope you learned something. I had one. So thank you all for attending. Thanks again for having me. And well, enjoy the evening and happy to share thoughts around a beer.